Much for the invitation, and I'll use slides. I wasn't really sure if I was expected to do it, but yeah, I was preparing them last week, and I thought that it would be good to create a bit of context what the role of AI is in climate, and in particular in climate adaptation. I'm going to talk for this about an initiative of the European Commission that tries to build a digital twin for climate adaptation. And this is part of the Destination Earth initiative that is funded by DG Connect. I come from Barcelona, and yesterday we experienced 29.4 degrees, which for the early part of April was the record in history since we started measuring temperature in the city. It was measured in a station that is really high up in the hills, and it's really outside the city itself. It has been measuring temperature and precipitation for more than 140 years. So it's quite a unique station, and the temperature, the maximum temperature for April was beaten by almost 2 degrees with respect to the previous record that was last year. So that's really telling. Climate change is happening. It's taking place now. Temperature goes up and down, but we haven't beaten a cold record for a while we beat warm records, if not every year, every second year. And this is only in Barcelona. It's not only in Barcelona. It happens everywhere in the world. So we have to do something. We know that we have to reduce emissions. We know that we have to change many of the things that we experience live, and the way we experience life, energy, agriculture, mobility. But at the same time, we have to adapt to a changing climate, to a climate that is changing very fast. And it's actually a climate that we are not used to it. At times we might feel that this is beneficial for us. Other times it's not that beneficial. And this is what climate adaptation is trying to do. Climate adaptation is the domain that is trying to consider all the different elements that are affecting the way we are living and we are going to live in the near future in a changing world. This is really taken very seriously by a number of institutions, and the private sector follows suit. It's very switched on. But an example is the European Climate Risk Assessment Report, which was a report, the first European assessment report on risks related to climate that was commissioned by DG Clima, and that was released last month and communicated to Parliament for its study. In these reports, there are many different components that come in because climate is affecting many different aspects in life, and in particular in this diagram, it refers to the elements that enter a risk assessment related to climate for infrastructures. But the really physical climate part of the whole story is very small. It's the part that corresponds to the light blue boxes in there. So the physical climate, so the changes in temperature, in heat waves, in sea level, are entering a very complex decision process that involves investments, regulation, that involves vulnerability, the needs of the different communities, the values of those communities, both cultural and personal. And that means that climate adaptation is quite complex. So looking at climate adaptation as one of the problems related to climate change from a technological point of view is a mistake. It's a social problem where technology can help, and it can help in many ways. One of the ways in which we try to help in centers like mine, the Barcelona Supercomputing Centre, is making simulations of how the climate might evolve in the future. And we do this with climate models that are models that try to resolve the equations that describe the evolution of the atmosphere, the ocean, the land surface, the vegetation, the ice over land and over the ocean. So all the components that are interacting continuously, and that's we investigate using these climate models in a coordinated way with all other institutions around the world that are ready to exchange information and coordinate those experiments. Climate is, physical climate in particular, is very special because it's very well coordinated at the global level. Europe plays an important role, but without the other continents, we wouldn't go very far. And very importantly, data is free, is public, and it's accessible to everyone. And that makes it very special because it's an ideal landscape for AI to express itself. The problem is that so far, all these different experiments that are used to provide climate information are being produced in the research environment. So they are produced, those simulations, by postdocs that are acting around the world and that are producing, with the best efforts, experiments every few years. And those experiments are quite useful because, for instance, they contribute to a unique exercise of synthesis of global knowledge about climate and climate change, which are the assessment reports of the Intergovernmental Panel on Climate Change. This is a unique effort that it has been already taking place every few years since the late 20th century. And it's driven by policymakers, but it's done by researchers, and it's owned by the policy. And it's very important because it is the science that underpins efforts on negotiations of climate and climate efforts, like the ones that take place at the Conference of the Parties, that are events that take place every year in different parts of the world, at times in very controversial places like United Arab Emirates, and that they represent the forum where the negotiations about the emission reductions and the adaptation efforts take place at the global level. This is the place where, for instance, the European Union announces its emission reduction efforts that affect all of us. In all ways, it's the kind of event that really has a very important impact on our way of lives. The problem is that there are many important decisions that are being taken on the basis of information that is being produced every few years with efforts from the research community. And as much as I like the research community, I'm a researcher as well as Professor Gruber, we are not really prepared to do these kind of things. We are not funded to do this thing. We don't have the careers to do this thing. It's suboptimal. So the community is thinking on a different way of working, and that different way of working is essentially the way that weather forecasting works. So basically, we need an operational environment where, with its dedicated funding that is responding to and it's addressing questions that are relevant to those that have to make decisions, both in the private sector and the public sector. So for instance, who can really provide information to the European Commission the next time it has to go and negotiate with China, the US, and many other countries that have to reduce emissions on CO2 and methane, for instance. And this is far from trivial because the community has been doing this in research mode for too long. So what the Commission has done is fund an initiative called Destination Earth that includes an effort to operationalize the production of climate information at the global scale. What you see there in the video, you could see it before, was the it's not a satellite image. It's a simulation. It's basically a model that is reproducing what the climate is going to do in the next few decades. And it's fundamental to be able to simulate what climate is going to do. One might feel tempted, why not doing it with AI? We have plenty of satellite data. We have plenty of observations like the one I referred to in Barcelona. Why not using all this? Because to describe what the climate is going to do, we need all the hidden parts that really define what the climate how the climate is evolving. The deep ocean, the the ice over land in Antarctica and Greenland, the land surface that goes well beyond the roots of the plants that we know. These are the places where the climate is actually changing, and we don't observe this. We cannot dip satellites into the ocean and try to observe how the turbulence is really moving there and where the heat is going to. We have to infer it, and we infer it using these kind of models. A new set of innovative models that run at very high resolutions that are extremely expensive, and that, for instance, we run on the largest supercomputers in Europe. In particular, we have been using in the last few months 5% solidly of one of these supercomputers that has a power of more than 300 petaflops. So this generates a lot of data. This data, we make it available immediately to the community at the highest frequency possible, as if the community was using an observational instrument that you can use to observe things as they are happening. And that we can also use to provide not just temperature and precipitation or wind, but actual variables that have a meaning to the community, in particular to the private sector. The private sector is not interested in the wind speed at 10 meters. They're interested at the wind speed where they have the turbines. And this is the kind of information that we are producing with Destination Earth. It's a huge amount of data, and that's where AI might come in as something really useful. So what role for AI? AI is actually very useful. It has been recognized late in our community, both in weather and climate, as a tool that we have to take seriously. The weather and climate community looked a bit, undermined a bit the role of AI in the last 5 years, because we were thinking that it wouldn't be able to compete with the way we are using and resolving the equations that describe our climate system. We were proved wrong. And actually, the community has been barging through to change this and to make use of the most important asset that we have, data. Data is our capital. Machines is a consumable. They'll disappear. The data remains. And that applies to all the domains, not just to our domain. Our domain is a privileged one because we have been exchanging data for 70 years already at the global level. Even with Russia, we keep exchanging data. Nobody wants to make a weather forecast without knowing what happens in Siberia. And that the Russians would never be able to do lots of the things that they have to do without the data that refer to the observations that are happening in the rest of the world. It's life-saving. I'm talking here of saving lives. But it's a business for the private sector, but it's at the human level, it's basically life-saving. And it's the AI is entering the climate community and the weather domain in many different places, in substituting components of the climate models that we use, in moving data and compressing data in many different ways. And I'm going to refer to a couple of those possibilities. One of them is we are producing in Destination Earth massive amounts of data. The weather forecasting community has been able now to produce weather forecast models at the global scale that compete with the traditional ways of making weather forecasts. There's no way to distinguish between these three weather forecasts, which ones have been done with traditional methods and which one has been produced with AI methods. Actually, one of them has been no, I don't have the NVIDIA one, but I should have had it, actually. So basically, AI is competing now with the traditional methods to perform weather forecasts for the next few days, up to 10 days. It cannot do it with climate, but we can really help, or AI can really help us. AI can compress these data into a set of parameters that we can use to reproduce the trajectories of the weather of the climate simulations and deliver the data of the climate simulations at the highest resolution possible on demand to whomever is actually asking for this data on basically a matter of seconds. And that this is what we are trying to do. Try to embed the AI capabilities into not the way we model the evolution of the climate, but into serving society to provide the data in the best way possible. And this is one of the, another example of one of the efforts that we are undertaking. One of the aspects that doesn't really scale is how we deliver the climate information for climate adaptation. Almost every sector of activity, of human activity plus ecosystems, is vulnerable to climate. But we don't have enough people to deliver this kind of information on a human basis. We cannot really dispatch people to all those individuals, companies and public administrations that need this kind of information. AI with large language models and chatbots is coming to the rescue, and even if it doesn't solve the problem, it can really make us go a bit farther and deliver this information in context, not just a set of graphs and figures, but also text and explanations that can create the context in which this information has a sense, and that, if we can, also take into account the values of those that are listening. Current large language models that are at the basis of these kind of exercises are suboptimal, in particular if we want to orient it to a specific domain. And this is what we are trying to solve in at the Barcelona Supercomputing Centre, with the use of different techniques that are available to refine, to fine-tune those large language models using what we know best. The information that is domain-oriented, that is actually the one that we have to give more weight when we are fine-tuning these models. And it's actually this what I was referring to before, data. This information, those documents, these experiences that people can refer, write down, use in the form of sound, and that we can embed into this new training of the models. And that's my last slide. All this is very good, but there is no reason why we shouldn't do anything similar that has been done already with the AI Act regulation. Climate services, as I said before, is life-saving. People's lives are at stake. We cannot just deliver information in the private sector, or in the public domain, without really having full traceability, having standards, and having labels that can identify what is trustworthy and what is not. And this is another effort that DG RTD and DG Clima are putting together in the European project Climate Europe 2, in which basically the goal is to end up with providing any piece of climate information with an information sheet that would be similar to the one that we find when we buy a paracetamol. There is no reason why something that can be damaging doesn't come with a minimum piece of information like this one. And that's it. Thank you very much.